Please ensure that you've submitted your Do Now using the Google form before you have moved on to this particular video. You will have been given permission to move on to the independent group if your Do Now was correct. So looking at this, this should be just quick and easy since most of you have already gone over it. We're always looking for the relationship between the original drawing and the new drawing. And so we can draw this quick T-chart. For the original, we add 1. The new is 1 1/2, its corresponding side. And for the original other side, we have 1/2, and its corresponding side is 3/4. So if we want to know what the scale factor is from original to new, that's just the same thing as a constant of proportionality. So we're going to have x and y. We're going to have 3/2, that's our 1 1/2 divided by our 1. It's going to tell us that the scale factor is 3/2. Let's just quickly double check that that's true for our other our other side to make sure that the scale factor was used consistently throughout. So that's going to be 3/4 divided by 1/2, which is the same thing as 3/4 times 2 over 1. Doing some cross canceling, we are going to get 3 over 2. So 3 over 2 simplifies to 1.5 is our scale factor. And we can come down here and the correct, remembering that our new is our y, we're always trying to figure out what our new would be based on our old, is going to be n is equal to 3/2 O. We can do the same thing over here. We see that this is a reduction rather than an enlargement, so we should expect that the scale factor is going to be less than 1. So original to the new. So our original is 1 1/2. Its corresponding side is 1. And our original is 3/4. Its corresponding side is 1/2. So our new over our old is equal to 1 divided by 3/2, which means we have 1 times 2 over 3, which is going to give us a scale factor of 2/3. Which means if we come down here and we look at our equation, we want new is equal to 2/3 of the original. So just a quick look at that, make sure that we have that right. We need to have that understanding before we move forward with our work for today. Alright, today Kipsters will be able to use scale and scale factor to find scaled values. So that's a lot of scaling going on. We want to make sure that we have a clear difference between scale and scale factor. So I'm going to come over down here. The difference between scale and scale factor. Scale does not necessarily have the same units, whereas scale factor always will have the same units. So it's literally how many multiples something bigger is than the other. So this has the same units. So this is like 1 centimeter to 2 centimeters, for example. 1 centimeter to 2 centimeters on a scale factor. A scale, on the other hand, would not have the same, so we might have a scale factor may not have same units. It could. But we're looking at an example, it's like 1 centimeter is 2 meters. And so when we look at that and we think about this scale here, our scale factor is not going to be the same as our scale because it is not going to be a 1 to 2 ratio, because when we have 1 centimeter, that is really the same thing or we have 2 meters down here, that's really like saying this is the same as 1 centimeter to 200 centimeters. So we can see there that that's not going to be the same. It's going to be 200 times different rather than 2 times different. So when we're talking about scale factor is always going to be that converted. So that's thinking about you would take the 1 centimeter to 1 meter. To make it a scale factor, you would make it 1 over 200. Centimeters to centimeters. So this is not a scale factor. This one definitely is. All right. So make sure that we have that vocabulary down with us today. That's really important as we move forward. All right. So Vincent proposes an idea of the student government to install a basketball hoop along the court. He presents a plan to install a half-court design. After checking with the school administrators, he is told that the court will be approved if it will fit the empty lot that measures 25 by 75 feet. Will the lot be big enough for the court he planned? And so we're given the drawing down here. This is what's most important. Given the drawing down there. And when we look at this drawing, we're told that there is a scale. And notice we're given a scale because it's 1 inch to 15 feet. So we could definitely turn this into a scale factor. Okay, so we have a scale factor of the original and the new. So if we're thinking about the original here, this is our inches. We could do it that way. To our new, which is our how many feet it is. We could do it as a scale of 1 to 15. Or it's possible we could also change that so it's not 15 feet. We could change that into inches. 15 times 12, which would be 180. So we could say this is 180 inches to... And so that would give us a scale factor that tells us that it's 180 times larger than the drawing. 180 over 1. So we're actually going to do this both ways. I'll use 1 as the scale factor of 1 over 180. And that's inches to inches. And the other way that I'll do it is with a scale factor of 1 inch is 15 feet. So we know that that doesn't mean that it is 15 times larger. It's much larger than 15 times larger, but I can still use it the same way. So when I use this one, this is always going to convert me inches to inches. So when I have this one, this is the new is equal to 180 times the original. So I'm going to start with this 2 inches down here. This is 180 times 2, which is going to give me 360. But remember, this converts from inches to inches, so this is 360 inches. Now if we want to figure this one out, we actually need to convert it down to feet. So I end up having to divide by 12 here to get this down to 20 feet. So this creates an extra step when we convert it like this in this particular problem. But we do want to remember that this is valuable to sometimes convert it to a scale factor because we might just want to know how many times larger it is. Coming down here, the other method, we would have the new is equal to 15 times the original. And I know that's a little bit confusing there with that O looking like a 0. Maybe O was not a good choice. But we put in our new here is equal to 15 times 2. You get N is equal to 30 feet. Alright, so when I go back, I definitely recognize here that my division was poor. This should be 30. We do get the same answer here no matter which way we do it. And as we can see, this is kind of one of the drawbacks of changing to a scale factor sometimes when you don't need to, is you do have to make that conversion basically twice. So when we look at this, there are two different methods of going about doing this. And you can kind of choose whichever one you want, but you do need to understand that in order to have a scale factor, to know how many times larger something is, you do have to go from the same units to the same units. So in this case, inches to inches. So coming over here, we have a diagram below. It shows a garden. Each square that is on here is 1 centimeter by 1 centimeter, so you should be able to measure out the length in centimeters on the drawing by counting out your number of centimeters. And it tells us that 1 centimeter is 20 centimeters, or is 20 meters long. So find the actual length and width of the garden based on the given drawing. And I'm actually going to have you guys do that independently on your own. So go ahead and pause the video for a moment and sort that out on your own. So looking at this, there's really two methods you could have gone with. You could have gone through and said your original and your new, you could have said was 1 centimeter is 20 meters. And so you have a scale, not a scale factor because it doesn't tell me how many times larger something is equal to 20. Or you could have said that your original is 1 centimeter and 20 meters is 2,000 meters, which tells us that our scale factor from the drawing to the real world is going to be 2,000 times larger. So we can think about that either way. It really kind of depends on which information we're trying to get here. This one says just to find the actual length and width. So for me, when I look at this one, I probably think that this is probably the easier path to walk. So I'm going to write my equation based on that. The new, which would be the actual size of the garden, is equal to 20 times the original. And I'm going to change this to an R. Just because I'm starting to get confused. Alright, times the original. Alright, so n is equal to, so when I look at this side, 1, 2, 3, 4, 5, 6, 7, 8, this is 8 centimeters. So I'm going to plug in 20 times 8. And this is going to tell me that this side of the garden is supposed to be 160 meters long. So again, remember, this moves us from centimeters to meters. So we need to get those units right. If we're going to figure the height or width of this garden, I'm going to use the same equation, 20 times the original, which is 4, and is equal to 80. And again, remember, this moves us from centimeters to meters, so this is 160 meters by 80 meters. Alternatively, you could have used n is equal to 2,000 times the original. So again, this is thinking about, this doesn't change us. This keeps us in centimeters. N is equal to 2,000 times the original, which would be 8, which would tell us this is 16,000 centimeters. And again, that's a choice. We know we can convert that back to 160 meters. So think about the drawbacks of one method over the other and the benefits of one method over the other. Hopefully in your mind you're thinking about some of the drawbacks, being that if you change it to a scale factor, you often have to convert back to a different set of units depending on what you're looking for. But the benefits of the scale factor is that you know exactly how many times larger something is in the real world. Moving on down here, we have a graphic designer who is creating an advertisement. She needs to enlarge the picture here, given here, so that 0.25 inches on this picture will correspond to 1 inch on the actual advertisement. So we're looking at our original, which is our drawing here. And again, I'm going to start calling this R just to make it easier. R for original. To our new. And we're going to figure out what that scale factor is. We're told that she needs to enlarge it so that 0.25 on the scale is equal to 1 inch over here. So this is 1 over 0.25, which is actually equal to 4. So we're going to be enlarging it. That makes sense that we have a scale factor that is larger. And this is inches to inches. So this is not only a scale, but it's also a scale factor. We know it's going to be 4 times larger. So we can go ahead and use our equation that tells us the new is equal to 4 times the original. So in this case, for the top, we have 9/8 times the original, let's go back and fix that again. We have 4 times the original value, which over here, this is 9/8, which is going to be 36/8. And if we simplify that down, we should get that that is 18 over 4. Um, 18 over 4. Actually, I can simplify that even further. It's going to give me 9 over 2, which is 4 1/2 inches. So again, we didn't change units from here to here. These are both in inches when we set up our scale factor that way. So it's still 4 1/2 inches. Finally, down here we're looking at this one. This is 1 1/4, which is going to be 5/4, and is equal to 4 times 5/4. And that's going to give me exactly 5 inches. Alright, so that's using scale or scale factor. We can see both here in these particular problems. Go ahead and flip on over to your partner work time and get those problems done. Go ahead and pause the video until you get that work done, and then you can watch the video to continue and go through and check. Okay, when we look at this particular problem, we're trying to figure out if this basically 10-foot thing is going to fit through this mall entrance over here. And so we're given a scale that tells us that on our original drawing, 1/8 of an inch is equal to 4 1/2 feet. So that means that if we're going to set up our scale, this is going from inches to feet. And in order to figure out whether we're getting this 10-foot thing through the door, I'm going to go ahead and set up our scale factor just as it is now. So this is going to be 9 over 8 divided by 1 over 8. Divided by 1 over 8. So that's finding my scale factor, or my scale, that I can use in my equation. 9 over 2, 4 1/2 is 9 over 2 divided by 1 over 8. So that's 9 over 2 times 8 over 1. Cross cancel, that's going to give me 4. And this tells me that we have a scale factor of 36. Alright, so that tells me that 1 inch is 36 feet. So I can write my equation. I'm going to do this over here because this is where we're trying to figure out whether the panels will fit. The new is equal to 36 times the original. And over here on the original, we're seeing that the mall entrance is 3/8 of an inch. So I'm going to plug that in. New is equal to 36 times 3/8. I'm going to do some Cross canceling 9 here. It's going to take out 4. It's going to give me the new is equal to 27 over 2, which is equal to 13.5. So that mall entrance is 13.5 feet wide, which means that yes, absolutely, our 10 feet will fit through that door. So, and determine if the panels fit. Yes, they will fit. Now, coming down here, this asks us what the scale factor is. Now, remember the scale factor is when it's same units to same units. So over here, when I want to go ahead and find my scale factor, I need to find my original is still going to be 1/8 of an inch. But my new, I need to be told how much that is in inches. So 4 1/2 feet, if I start thinking about that, that's the 4 feet is 12 inches, 12 inches, 12 inches. That's 48 feet. Plus another half of a foot, that's another 6 inches. That's 54 inches. Okay? And so my new divided my old for my scale factor, where they're both in the same units, tells me exactly how much larger it is. 54 divided by 1/8 ends up being 54 times 8, which is going to be equal to 432. Now specifically, what does that tell us? That goes back to what we were talking about previously, that the scale factor itself tells us exactly how many times larger it is. So what does it tell us? It tells us that the mall is 432 times larger than the drawing. Okay, so remember, looking back at our aim today, we're supposed to be using scale and scale factor because we need to be able to identify the differences between both of those two things. All right, so that should be it for our lesson. Please go ahead and move on to your independent work to go ahead and prove this. And then again, once you're done with that, move on to either your personalized Khan playlist or either of the 2 scale modules that we were talking about yesterday.